This is Anita Wood, and the topic snippet we've got here is for 125 Module 8. And we're going to introduce constructors and review variable scope. So one thing I do want to make an aside for, when we've been defining classes so far, the thing I have not made a point to mention, and I'm doing so here so that your assignments will work better, is when I create a name for a class, we have to realize the class is a template and it will be used many times, but it represents one object. So with that, then what we try to make sure we emphasize is our class name is using single nouns, not plural. Okay, so what we've had so far is we've done it, but I haven't made a point to show you and say this. So if I'm doing rectangle, book, and an employee, now the class is a template for one employee, and it can be used over and over again, but each time it's used, it really is only representing one employee. That's what's important here, not employees. Okay, a quick review so that we understand what we've got going, and when we add this new item called constructor, we can see the value of it. Here is my class rectangle. We've been working on this one. Okay, it has fields which are private. Okay, it has methods which the ones we're working for are public. You can have a private method in here, but it means that only other methods inside the class can access it. And that's not the world we're working in. That's more of an advanced world. So all of our methods are going to be public. We have setters and we have getters. For every variable that is private inside here, hidden from the outside world, we will have a method that the main program, the main flow, can call to actually put a value in there or get the value from there. And that was what we talked about last time. So then we have our main program where we have a class that we've defined over here. Okay, and then we end up assigning a variable name that will be representing this class. So I'm actually declaring shape 1 to be of data type rectangle. Rectangle is a class, and classes are a way software developers can define and create their own data type. Okay, so if you look at this, this looks very much like if I said int shape 1, because what I've done is I'm mimicking the same thing. I'm taking, and this is my data type. That's why it starts with a capital R. All right, it's trying to distinguish the fact that it's something that I have declared. What I've done now is I say I am going to take shape 1, which is my variable, and it's going to be of type rectangle. And this statement in pseudocode is what we're going to call, we're going to instantiate a class to make an object. In our terminology soup, we know that we could say object, instance, okay? So that if we use it, that this is an instance of the class, then this instantiate is a little bit closer to making sense. Now I can reuse as many times as I want this class, and I have here. I have used the shape2 variable, which will now be of type rectangle. And I also have two other variables that are local to my main flow for area 1 and area 2. Now, I've set up shape 1 and shape 2. Shape 1 has its own instance of everything in rectangle. All right, and it's set up in memory to point to its own instance. Shape 2 has its own instance of rectangle. With that being said, it's also got its own area in memory that holds these values. So when I do and I need to get a hold of the stuff that's in here, I do so by using a dot. I give you the class name and I use a dot. And what we're using right now are just the methods that we defined. The set the length, and we're going to set the width. These are our setters, which allow us to go and get a hold of the values. Well, excuse me, we're going to set the values of length to whatever I send in. So I'm sending in a number, and it has a parameter argument or parameter variable, and I set that, which is that value, into length, which is this value. Then I call another method that is in my shape 1 class, and I calculate the area. And notice this calculate the area, it doesn't get any parameters because it's going to go into shape 1 and use this calculate area that is associated with the class shape 1. So that class is the method is over here inside class, and the length and the width are the lengths and the width that are in the class. And if I set the length and the width for this particular instance, it's 10 and 10. So there's a 10 and a 10 in here. And when I calculate, it uses the 10 and the 10 because I called and said shape 1. And if I do the same thing here for shape 2, put 100 and 100 in as the length and the width, when I call this calculate area, it's calling the one that's associated with shape 2, and it's the length and the width for shape 2 that we set up. Okay, so that's just another time, and I'm being repetitious, and repetition is for a reason. It really is this concept of classes, instantiating it to make an object is something that takes more than 1 or 2 times to be stated to make sense. So what I want to do is, I lost something here. So I have this term constructor. Now I'm actually constructing. Okay, and what I'm constructing is the class. Okay, so I have this concept of a constructor, and it gets called once, and it's actually a method that is inside of my class. Can you see it here? Actually, it just looks like this. Put that over here, and that's what A is pointing to. I don't know what happened to it. So now here is my main program, and I'm giving it the class name, and I'm giving it the variable that's going to be pointing to. This is the object, and I have a little bit more information that I've provided here. And what I'm saying is, it's nice to create an instance of rectangle and put it at the pointer to it in shape 1. But I can also, when I put together this instance, I can do some initialization. Okay, so when I'm creating the instance, when I use new and repeat this rectangle, which is a method call, which actually, as I said, it's over here in my class definition. I'm always sitting here circling around these blank spots in my PowerPoint. I apologize, especially for this one. This was bad. And what you will see I get to do is I'm creating a area, a method that's going to let me do some more things like initialize my variables by sending through variables that are private in shape, like length and width. So let's look a little bit better here. There we go. So I have different constructors I can create. This one, which I pointed to, which is over here, okay, and notice it's not sending through any parameters. There's no arguments here for it to be accepted over here as parameters. So when I have this constructor being called that has no parameters, nothing gets set. None of the variables are going to be initialized. But if I use and create an instance of the class and create object called shape 2. This constructor, and it's a constructor because first it's right after the word new, and it has the exact same name as the class. Two things that allow you to understand. When I'm in the main program, it's whatever follows the word new, and it has the same name as class. So it looks like I've repeated the class name, but this is the class that I'm going to use to create the instance that's in shape 2. This is the constructor that I'm going to use to initialize these variables that they're private and they're located inside the class. So here's two numbers that I'm sending through. Okay, I have two arguments. I have 100 twice. So what's really going to happen when this instance gets created is I'm over here in my class definition. We don't have these in there yet. We will be putting them, but there will be this area called constructors. There's going to be one that is just sitting there taking no parameters, so no initializations being done, and that's what I do here. So I can call it. There's going to be other ones we can place in there. Same name, okay? But what happens is this one has parameters. It has 2 parameters. Over here, it has 2 corresponding arguments. And because it's the number and the type of arguments that are in here, so I know which constructor to call. So I have a number that represents length and a number that represents W. It's a corresponding thing like every method call. 100 goes in length, len, and 100 goes in W. Part of my method, I have to write this, is I'm going to sit there and go, okay, I'm going to put this value in, which represents length, in length. This value, which represents width, in width. Okay, much like my setters. But what I'm doing is I'm initializing them right at the time of instantiation. So that's what a constructor is. It's a special method called once and only once, only allowed to be used once, only allowed to be used after the word new. So let's start picking apart where we go and represent this. Let's start with our UML diagram. Here's the name of my class. That's in the very top box. Second box has all of the attributes, fields, properties, characteristics that I want to have for my rectangle. We are calling them private because we want to hide them. Nobody from the outside world is going to be allowed to get a hold of them. Only the methods that I define down here can interact with the attributes up here when they're private. So these are the methods we've written previously, okay? And to be even more complete, oh, I can't do it. Sorry. I can't do it because I have it on slideshow. I would have a num, and that I would accept a number here as a parameter. And for the set width, I could put num in there and be more complete. Just point that out. Because up here, I have my constructors. They don't have to be in red. I did them so they stand out. What they have to do is, first of all, be public, because I got to be able to get to them from the main program, and they must have the same name as the class. Now the very first one here that has no parameters is going to be called my default one, which means I'm not looking to initialize anything with that. The second one, I do accept 2 parameters, which means that I'm going to call it from the main program, and I'm going to send it, and then the method that I write to represent and fully define this method is going to take 2 parameters. So that is my UML. That's where and how I represent them, the constructors. So what do I do in the code? Okay. What I've changed is a couple things here. First, I've moved my comment or my conversation from rectangle class to the object shape 1 and I say I'm going to call, and when I instantiate, I'm calling the constructor rectangle, but I'm not going to be doing any initialization in this one. Second one, I'm going to create an object shape 2 based on class rectangle, and I'm going to call the constructor rectangle another constructor called rectangle that's going to accept 2 arguments from me. Okay, so let's look over in my class. I put a new little heading here called constructor. I have a method that does absolutely nothing in here, and I put the word default here as a comment just so we can understand that nothing's really going to happen in here, but I need it here just to be thorough. I have another constructor that is set up to accept 2 parameters, just like what I said, and this constructor, notice what I said, it has some initialization responsibility, okay, because it's bringing in parameters. So I should take those parameters and assign them accordingly to the private variables that I've got, right? And that's how I get that in the code. That's how I get this in the code. Now let's look on and beyond and see what we've got. Notice when I have my object shape 1, I didn't do any initialization. So I still need to set the length using my setters and my my setters down here. All right. So at the start, I still need to get these set up. And then I have my shape 1. I commented out shape 2 setting because I no longer have to do it. I already initialized it up here. And then I just can go on and say shape 2 and calculate the area. Now, like every initialization, I can always overwrite, these are the initial values, and if I come down later in my code, I can go and set length to another number, okay? And then when I do the area again, I'm going to get the 50 times the 50 because I set the length in the class, okay? So that's what it's going to look like, a constructor. So hopefully that helps us because we do need to design some constructors in this one assignment. What I want to go and talk about is something we see it in Blackboard, and it's this, okay? I put it in quotes because it truly is a keyword, this. And when you see it, it's confusing, and it really is not meant to be confusing if somebody just spends 2 minutes telling you what it is. So I'm going to give you your 2 minutes. So this is my class representation. All right, this is a place I could use it. So this is just a good example of how this could work. Most of the time, you're using this when you're inside a method. Okay, so I don't have it in this one, but I have it in this one. Don't you hate me? So I have length, which is private to my class, and width. And I have my setter. I have a setter for the length and I have the setter for the width. Now notice, for instance, in width, do you see the parameter variable that I'm using here? I was specific to make it look different than what it was going to be assigned to. So this variable W, fairly easy to recognize what I'm trying to do. I'm taking this variable W and placing it in width. Now, programmers like to sit there, particularly when they're doing setters. They want to make sure that not only do I have the variable name here, which it's a best practice, it's not a mandate. They end up saying, I'm going to send through a value, whatever it is, and this is the parameter, and I actually put the variable name here. And it's going to be a local variable. But now I've got length that comes in from the outside and length that is supposed to be on the inside. What we want to do is, if I want to do this assignment, what length is on what side of the assignment? Because it could be either way. It could be the red one over here and the yellow one over here, or the yellow one over here and the red one over here. To help distinguishing which length I'm talking about, they have a prefix they use called this dot. When I use this dot, the length that I'm getting a hold of is the length that is already present and declared inside the class. Okay? So it's this length, and that's why I made it yellow. That's where you use length. It's because when they gave me and they wrote up the setter or any other method, and it's going to have the variable name here that already is inside the class, which it's allowed. And it's allowed because I can distinguish which one I'm using. If I'm using the one that's internal to the world I'm in, I use a this. If I'm using the one that came from the outside world, don't preface it, just let it go. Me, you'll notice I tend to try to send through variables and name them up here in my method, something different, so I don't have to play this game. What I'm trying to prepare you for is people use this. You're going to read a lot of code that takes and has this sitting there, and you're going to go, I don't understand it. Well, now you do. There was your 2 minutes. Okay, I want to spend another little bit, and this leads us a little bit, gives me a nice transition into scope. And I want to review scope. We did it very early on, but now we have so many things going on. It really is a nice refresher right here. Scope is where in the program the variable can be accessed by its name. Okay, that's a pretty simplistic definition, and hopefully as I go through this it will sink in. So I declare variables, okay, and where I declare them is going to determine its scope, where I can access them. So think about the different places I can declare a variable. I can declare a variable inside a method, okay? Now when I do that, the variables that are declared inside a method, they're going to be called local. Now don't try to memorize this or write this down. I have a picture. When I declare a method inside a class, but not inside any of the methods for that class, very much like these are variables I'm declaring inside a class, but they're not inside a method. What I want to call them is fields. And notice it responds and corresponds to this little header that we are starting to use when we define classes. When I declare a variable inside parentheses for the a method header, this is a method header. This is when I define it. Public void set width. It's this guy right in here. I'm actually doing a declaration because there is the data type for this particular variable. This guy right here, we're going to call parameter variables. So let's identify those in what we've been working with. Here is a class. Here are the fields. I'm defining variables that are not in a method in a class, and I call them a field. Right there. And here's my constructor. Okay, remember, a constructor is just a special method, and I'm allowed to send in arguments, which become parameters. So they have a declaration of a type, a data type, and a name that then I use inside of the method. Those are going to be called parameter variables. The constructor has them, and just general methods that I have. Here's general methods. The methods don't have to be in a class. Okay, they could have been out here. It's just I was using the code that we've got going, but they can be over in my out here, a static method that exists out here. And the same thing, anything that's between the parentheses in my method header is a parameter variable. Now, when I'm working inside a method, notice I kind of blew this up a little bit just so I could get there. I have a declaration inside my method, and that's called local. All right, let's go over here. Here's my main method. My main method is a main method. So whatever I'm declaring inside here are also local. They're only available inside the whatever's happening between the start and the stop. They're local to the start and the stop. Let's go for it again. So local variables, okay, the scope for a local variable is the method in which it's declared. So it starts at the header and goes all the way to the end. And for us in pseudocode, that's the return. Fields, which are in classes, the scope of them is all the way from the definition of the class to the end, okay? That entire class. Parameters are coming in, and they're parameters for methods, so they are also accessible only inside the method. So let's look at the pictures again. Repetition is painful, but hopefully valuable. I have fields. The green box tells you the scope of the variables that are fields, length and width. They are variables inside a class, the entire class. I have a parameter variable for the constructor. They come in as parameters. The scope of lang and w is only within the constructor here in this method. I have another parameter variable that's coming in and being declared in the header set length. The scope of len is only in the method. I have a local variable that I have defined inside a method right here. Its scope is only inside that particular method. One more. I have local variables. I have an object I've defined, and I have a primitive data type of number, and only inside of this method, which our main flow, this is a method for us. Okay? So there, constructors, a little bit of a review about variable scope since we have so many places now. Hopefully that is something you're going to find very valuable.